Hello and welcome to another video on our further math series, and this is once again on T1 EDEXCEL, and we're looking at chapter 4 now, which is root inspection. All right, couple of definitions before we go on. If you want, can you just pause the video for a minute and just try and write down what these definitions are according to you if you read the book, and then compare the answers with me. We'll discuss this in a second. Right, so here we are, graphs where all vertices are even or have even valences, order or degrees. So we've discussed this in previous videos. The vertices with the degree of the vertices, how many edges are incident to those vertex. So if all of them are even, the graph is Eulerian. Okay, if only exactly two of them are odd, graph is semi-Eulerian. And traversable graph is a graph where we can go from one point and go through all the edges, one node, go through all the edges without repeating any edge. You can come back to the original point where you started from. And semi-traversable is the graph where you start from one edge, go through all the edges without repeating any edge. You can go out of the graph from a different vertex. And all Eulerian graphs are traversable and all semi-Eulerian graphs are semi-traversable. Let's do an example, guys. That's a network. Let's say this is A, B, C, D. This is Eulerian because all of them have valences of degrees of 2. So we can start from any vertex. So A, B, C, D, A. We can come back. D, C, B, A is the simplest graph, right? What we're going to do now, let's do some extensions here. Okay. Now make these two edges as well. Now let's see what's the word is here, guys. This is 3, 3, 3, 3. These are the valences or the degrees of these vertices. So this graph is not Eulerian because every vertex is not even. This graph is not semi-Eulerian because every only two vertices have to be odd in semi, but we got 4 of them. Let's see, is it possible to traverse this graph starting from A? Okay, A, B, C, D, B. Now I cannot come back to A without either repeating this arc or leaving this arc as well. So guys, this is not traversable. So can I start from A and go out at any other vertex? Let's see, A, B, C, A, D, C. I've missed that. So I cannot go out of any of the vertex there as well. So guys, this graph is not semi-traversable as well. Now let's do some extension here, guys. Let's make another node E. Now let's see what type of graph is this. The valences here are 1, 2, 3, 4. 1, 2, 3, 4. So this is 2 and this is 3. This looks like this is a semi-Eulerian graph. So I should be able to traverse along this graph without picking my pen and redrawing any arc. Let's see if that's possible. So A, D, C. Hope I do this right. B. And now this one, this one, this one, and this one. Okay, so I can go back from different vertex, which is odd. So I can start from C and finish at odd. I can't start from A there, guys. So I can start from C, finish at D, right? Without traversing any of the other lines again. So that's semi-Eulerian graph, people, right? And if I join it here as well, let's say this is F, so that's 2, this is 4, this is 4. This is Eulerian graph, so I should start from any vertex and come back to same vertex. Okay, that's the definitions part of it. Now we're going to be doing how do we actually use this root inspection algorithm to find the root. Okay, I'm going to come on to that now. Right, in exercise 4a, we talk about these definitions we worked on, and it talks about finding the root between in a network starting from one vertex to the other, where we have at the most 2 odd vertices. Okay, I'm going to leave that for you to do it yourself because this is easy. When there are 2 vertices, you start from any of those 2 odd vertex, and you should be able to traverse the graph and come out of the second odd vertex. Exercise 4b, which I'm going to be focusing on today, we have 4 odd vertices and there's a lot of scope for people to lose marks in marking schemes. I'm going to go over those techniques today. Then 4C, which comes in year 13 A2 level in D1 course. It's not an AS course where you have more than 4 vertices. So guys, we will be now looking to apply route inspection algorithm on the graphs which are non-semi-Eulerian and obviously non-Eulerian as well. Okay, the target is we'll make them semi or make them Eulerian so that we can find a route. We can find a route without picking up pen or repeating any of the arc and covering all the arcs and hopefully starting and ending at the same point, same node. Okay, so let's do some questions from the book. All right, the first question which I've decided to do is exercise 4B, question number 3. Okay, I mean, if you get time, pause the video for a second and go and have a look at the question. Okay, the question talks about it's a diagram representing network of cables joining computer servers in a university. The numbers on each arc represents the time in milliseconds taken for a data packet to travel along each cable. An analyst wishes to test the network by sending a data packet on the shortest possible route that traverses every cable and least once, and which starts and finishes at the server A. Right, this is a typical problem where you want to start and finish with server A. Okay, that's where we're starting and finishing it. Okay, and then we're going to be traverse each of the cable at least once. Okay, so we're going to be doing this step by step now, this algorithm. Step 1 is, people, identify all odd vertices. Okay, so please do that. Pause the video and do this, identify all odd vertices. We'll see how many there are. Right, I'm sure you have identified these 4 vertices I, B, D and G as the 4 odd vertices. And now step 2, we're going to do make all possible pairings. Pairings means joining 2 at a time of these 4 vertices. And guys, this is where I will tell you, you make the pairings. To be systematic, I'll make pairings as IB and plus DG. That's number 1. Then I'm going to do ID plus BG. So I to D, then BG. Then I'm going to join I with G. Number 3, IG and plus BD. So these are the 3 pairings I can make with these 4 odd vertices. Now I'm going to work out the shortest route going from I to B and right down there, and D to C and so on for all of them. Okay, can you please do that yourself? Let's see, and then we match the answers together. Right, so let's have a look. From I to B, I've got the shortest path is the straight path, 32, so that's 32. D to C, that's C, and that's G, that's G. Okay, D to G, and D to G is the shortest path, which is straight one, is 18. So total distance between them is 50. Right, so I to D. The reason I left this is I thought I need to do this with you. I to D, there is no direct path there, so you have to pick up the shortest path. You must write that which route you've gone. So I to D, you going I to E and E to D. That's the shortest path to make it 42. So I'll write down here I, E, D. Okay, that's the arcs I'm going to be repeating if this comes out as shortest. So I to E, this is 23, add 19 is 42. And similarly, B to G, there's no direct path, so I have to go from B to E and E to G. Okay, B, E, G, and this gives me 20 at 17 is 37, so that gives me total of 79. Obviously that overrides this. Okay, and this one is 52. And very important that you have to, now this is the shortest, I have to show something of some type of signal to tell the examiner that I'm selecting this one because that's the shortest path. Guys, your marks first, like I said, I'll tell you. First mark you get if you identify 4 vertices and write down the 3 pairings with at least 1 total, right? Then second marks you get if you got all the 3 totals and all the 3 totals are correct. And very important, the next mark you get, people, if you show us that you've selected the shortest path. So you must make all the possible pairings and select the shortest path to get that mark. And then you've already done it. So the total weight of the network was 326. So what you need to do, we have to repeat these arcs I to B. So I to B is this one, and I will show that on my diagram. And then D to G, D to G is this one. I'll show that on my diagram as well. So I'm going to repeat it right down here. Repeat I, B, and DG. Right guys, quickly over here, if this was the shortest and then I have to repeat the arcs, I will not write ID, I will repeat IE, ED, then BE, EG. I have to write this separately. If I write ID and BG in this case, if this was shortest, obviously we're not selecting this, but if this was, you have to write down the complete path which you need to go from I to D and so on. So guys, now the total weight of the network is 326. So route length would be 326 plus 50, so 376 seconds. I think it was time in this case. Okay, so that is your length of the shortest route. Now guys, what we need to do, we have to work out the route. There are many possible routes there. I would like you to try and work out a route yourself. Remember, what you need to do is you should be able to traverse all the arcs at least once, and you should be able to move into that network without picking your pen up or without repeating an arc. When I say repeating, from I to I to B, you're allowed to go twice because there are 2 arcs there, but you cannot go I to A twice because there's only 1 arc there. Alright guys, give it a try and we will make a route together afterwards. Alright, but be very careful. I'm going to give you a couple of important indicators that what you should do when you make a route. First of all, if you can, if it's possible, count all the arcs in the network. Let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 17 and 18. So the 18 arcs in this whole network, including the 2 arcs which I've drawn again. That means in my route, I should have 18 plus 1, 19 nodes, 19 vertices, because I'm starting at A and finishing at A as well. Okay, so let's make this route now. Okay. I will use pencil if I have it, or a different color pen. Let's take different color pen. Let's be brave. Okay, so I'm going to do from A, and I can go from A to I or A to B. Okay, I know if I go from A to I have to come back from B. So let's start. Okay, people, A to I. I'll keep writing there as well, A, I. So that's why I use pencil. It will be better if I can do that. Okay, so A, I. Right, and then I do I to, where can I go, H, and H to G. Okay, so H and G. So I want to see this, that I'm making these arcs again. So now I'm going to go from G to I again. Can I go back? Yes, of course, because there's arc, and then it from here I should go anywhere, and I can go it here, E, C, D, right. So rewriting it neatly, as you see, I was rubbing this off because I've mixed a couple of them. this is the route we're going to take, guys. Make sure you try it a couple of times. I don't know what is the route. There might be many other routes possible as well. I would probably ask you to try one more and see if that can work. Okay. All right, so let's try. If you haven't done it, let's try this together, guys. What did I do first time? I went from A to I. It's the only way. The other route is I have to use, probably I go from A to B. Let's see, what do I do, guys? So let's see, A, B, then C, D. Okay, I'll write that down as well. I'm using A, B, and C, D. Then I'm going to go from here, B, then I can go to I, then I can go to E and B. Let's do it in 4 parts. So B, I, E and B. Okay, so from B I can go to I back again because there are two arcs there. So I, then I can go from I to coming down this way. I can go to G, and then I can go to D. Okay, yep. So E, B. Okay, B, I, E, B. Right. So B, then I, G, D, F. Let's write these 4 down now. I, G, D, F. So I, G, D, F. Then from F you can go to G again because that has been visited again. Then G you can go to E, that has been visited. G, E. Then you can go to D. Yep, you can go to G there and then come back to G because there are two of these. So this is, let's copy them down as well. We got G, E, D, G. So guys, we're at G now and we have to come back through this route. So this should be very straightforward. From here, guys, we're going to go to H, then I, then A. So H, then I, then A. Okay, so let's see, do we have that parameters there, guys? Do we have 1 2 3 4, 1 2 3 4 8, 1 2 3 4 12, 1 2 3 4 16, and 1 2 3 4 19? That's right, we wanted 19 there. We wanted 19 nodes. Then we're going to see if your arcs which were repeated was IB. Is it been repeated in both of them? That's IB once. And do we have IB again somewhere? Yep, that's IB twice. And this is DG, DG once, and that's DG twice. Okay, here over here IB once, and IB again, and DG once, and DG again somewhere. Yep, there you go, DG again, guys. So everything is fixed. That is the correct route. Okay, we're going to do another question now for you to practice, right? Alright guys, the next question I've decided to do is mixed exercise question 4. So take a pause for a second and read the question, please. Thank you. Hello, and come back then. Okay, so this is question number 4 of mixed exercise 4. Part A asks us to work out the odd vertices. So I've got this 4, guys. This is D, F, H and I. So can I ask you to make the 3 different pairings of these 4 vertices D, F, H and I, and then find out the shortest path between these pairings. DIY, let's do that and match the answer later. Alright, so these are the pairings, and to get the first mark I have to show the 3 distinct pairings between these 4 odd vertices and do at least 1 total, and for the second mark I have to go to get all the totals correct. And guys, then I have to select the shortest path, which is DH and FI, and luckily DH and FI are also the straight arcs between these 2 vertices, so we will be repeating these 2 arcs straight. Let's do that on the diagram. So DH and FI needs to be repeated, so DH and FI will be repeated. Okay, so total weight of network was 725. So length of the shortest route, which covers every arc at least once and starts and finish at the same vertex, okay, is 725, sorry, plus 49, and that comes out to us whatever, guys, you can do it better, and the answer is 774. Right, the target now is, guys, we're going to be working out the shortest route, okay, which is 774, length of 774. Let's work out how many arcs do we have. then that will tell me how many nodes I'm expecting to get in the shortest route. Okay, 1 2 3 4 5 6 7 8. Then if I go that way, 9 10 11 12 13 14 15 16 17. So I'm getting 17 nodes. Okay, so 17 arcs, sorry. So I should be getting 17 plus 1, 18 vertices or nodes in my route. Okay people, so I leave that to you for once again. Can you please start and finish at A and try and get a route which traverses all the arc at least once, okay, and comes back to the same point, and we want to work out the shortest route. Once again, the target is that you should be able to go through all of them and without picking your pen up, okay, without retracing something which is not double, like we'll have to double these two, right? Okay guys, thank you very much. Let's start then. Okay, I'm sure you've done it. Let's try this one more time with me, guys. Starting today, I'm going to go A, D, C, E. Okay, so let me just write that down as well. And then from E, I am allowed to go to anywhere. So let's go G, J, then come back to E again. Can we? Yep, we can. And then we go back to D there. Okay, so I've already done G, G, J, E. Let me just write down G, J, E, and D. So from D, let me go to H, and then I can go to I. Yeah, there we go. And then I can go to, from I can go to J. Then I come back to J. Then I come back to G there. Okay. So let me write down H, I, J, and G. Right, so we were on H, I, J, H. Let's do D. Then I can go to D, F, I, F. So let me write down these four: D, I, F, D, F. Sorry, D, F, I, F. I went there. Okay. Then from here I can go to B and then A, B and the A, because I know I had, because I've gone through this route, I have to come back to that route. Okay, it's 4 and 4 and 4 and 4, 16 and 2, 18. So we match that. Let's check if we got that thingy right, guys. Is arcs repeated? DH, is it repeated twice? DH once there and HD once there. Okay, then if I repeated FI, that's right. So FI, yep, FI and IF. There you go. So guys, we match all the requirements for this route as well. Make sure that you use a pencil or a different color pen, and be very careful that you're not, they keep recording as well. If you just go into the route, you might forget which direction you went into. So that's why I've just picked up this. This is what you can use as well, or whatever works for you. I just do it in 4 vertex at a time, and then see from there where do I go. Okay, this is how we do route inspection, finding the shortest route, and which is starting from one vertex and finishing in the same vertex. Okay, obviously there are some variations. We can come to that a little later.